No problems.
No, of course no problem. Come on,
There are often problems, so just for the viewers to know.
Not on my pumps.
There's a lot going on here. Just reviewing this one, I was trying to understand a little bit more about it, so I was asking some questions here, and I learned something I didn't know, which is how to test for the volumetric efficiency of a closed-loop pump.
How come this is so large on this pump?
It's that size because they use it from 135 to 280. There's 2 ports, there's a 1 port. They have different sizes.
What's that called?
That is the filter eliminator block.
But this size could have a filter, right? So this is just...
So basically the filter looks exactly like that, but it's machined in the back end to accommodate your bushing, to attach your filter, and the machining on the inside is a little different.
And this is the charge relief?
Correct.
The charge relief is in
the filter eliminator block.
In the filter eliminator block. How much flow is coming through here? What size pump do you have?
We have a old Denison PV6. So we got about
16 cc.
Yeah.
And that's enough for this one. That seems quite small for...
Just enough to do the larger sizes.
Maybe an older pump, maybe it wouldn't be enough or something? Or?
No, it should be if it's repaired properly.
Okay.
If we're running it at 1800, it might be a little bit on the low end, but at 900, it should be good.
So what efficiency are you seeing on this 210cc?
Okay, that's where we got to watch on this because this one has actually been de-stroked to 180cc. We haven't run the test yet to see what the efficiencies are. Now, I'm assuming if you de-stroke it a little bit, it might not be as much as when you're on full because you've moved it.
So we wouldn't know the efficiency until we try to put it up to the max, right? And then measure it? Or?
Right. We wouldn't know the efficiencies until we run our tests, so then we could take what it is at standby pressure and then at 4,000 or 5,000 or just before the POR kicks in. Because it is a closed loop pump, you're always going to have case flow. So if I'm putting 6 gallons in like we are now, I should be getting 6 gallons case flow. If I have a larger pump and I'm putting 10 gallons in, I'll probably get 10 gallons case flow.
So how are you determining the efficiency then?
What we do with the efficiency is that we take our pump flow, so the 43 gallons will be at standby pressure. Our POR opens at 4,300, so I would go to 4,000 PSI and see what our pump flow is. So if I have 41 or 42 gallons, then you divide that 42 by 43 and it gives you your efficiency.
So you're looking for how much the flow drops as the pressure goes from low pressure to high pressure.
Exactly. We've already done our beginner control. We've made sure our max volume is set correctly. We've checked our POR setting and it's correct. So now it's just a matter of running it to show it all on one graph. I'm going to put full flow to the unit. I'm going to put full pressure to the unit. That way we can show where our POR setting is, where our beginner control is, where our end of control is, that our max volume is set right.
So when you say full pressure to the unit, are you talking about the pressure override you're going to set to max or the relief valve, the load?
I'm going to put a load on the pump that's going to go to the crossover relief, which is the maximum pressure the pump can go.
Do you want to just do that baseline again? Just
you'll see it all in the test. Once the test is done, it'll be a lot clearer.
Okay. We'll take his word for it.
So we'll run the test now.
Okay, so now this knob over here is the driver card that's driving this proportional solenoid. And this is turning it, saying, is applying power to this will turn this thing on. So it'll turn the pump on that side. And he's going to say full flow.
When we put our full pressure to it.
Full flow, you mean?
Yeah, we have 300 PSI right now for our signal pressure.
That's the servo pressure?
Yep. So I bring my pressure up. I got my full signal pressure. When I hit my POR setting.
So the POR is when it's going to override whatever signal you give it.
So now it's decreased my signal pressure and my flow comes down. So now I still have the same electric signal going to it, but my POR is lowered.
Oh, the signal has gone down because it's in neutral position.
No.
The signal pressure?
The signal pressure, the spool opens up and allows the pressure to go to case.
Yep.
So that the pump needs X to go to here. It lowers it so that it proportionally brings it back down.
That's right. So then the spring inside of it moves it back into the neutral position.
Yep.
Okay. So as soon as the POR hits you want to see the signal vent, basically, so the spring puts it back into the middle.
Exactly.
Okay.
Before we hit our POR, we got 40.6 and we're at 4,000 PSI.
And you already set this one to 180 cc, correct?
Yes. So we got 40.6. So then we come up here where we're at 42.9. We're at 94.
94.6.
Yeah.
You have 10 cc of leakage, and you have a 16 cc charge pump.
Yeah.
So you're good.
Yep.
So it's saying that, yes, it's a closed loop, but it's not 100% closed loop.
So
it's 94.5% closed loop.
And this is why I was saying on the open loop and the closed loop, why they gotta watch the differential. There is a difference, sorry. Here's our case flow. So our case flow doesn't actually go up or down with the leakage, because on a closed loop, you can actually lose it from A side to B side, across the barrel from A to B.
Okay.
So that's why you can't use your case flow as a barometer to see how much of your failure is or how much your leakage is.
I had come in here because I was wanting to learn more about this, and I had asked, they're talking about the efficiency of it. I says, why can't you just measure the case flow? The case is the amount that's leaving the system. So it is a closed loop. It's not 100% closed loop. There is still flow that's leaving the system. But the efficiency of the motor, though, is different. It's different than the amount that's leaving the system. It could also just be fluid that's cycling in the system, not doing any work. Meaning that it's just going from, this pump is just going from the A to B side, back to the A side, to the B side, cycling inside the pump, and that would be an inefficient pump. So the charge pump, though, would be making up for the flow that's leaving from the case here. So we have 95% efficiency, though. That doesn't necessarily mean that you need 5% of a charge. You could still use less charge. It really depends on the case then, for the charge flow.
You want to have your charge pump properly sized to your closed loop unit, because your closed loop unit, you could have leakage from your pump, the motor that it's driving, the cylinder that it's driving, or the conveyors or whatever system you have, the leakage in the valve.
Right.
You want to have it for all that, because if you're having leakage in your system, your charge pump is keeping that loop full.
Yeah, but what I'm saying is that the charge flow that you put in here, this was not specified from the customer. This was just what you decided to put in there.
That's what we have on hand.
That's on hand. And it is just to make up what is leaving the system, not the inefficiency of the pump.
Yeah, just to keep the loop full.
Okay.
Yeah, I think I remember them saying, whatever your system flow is, you want to have, I think, 20% for your charge pump.
Okay.
So if you got a 100 gallon a minute pump, you want a 20 gallon a minute.
Yeah, it's just sort of a rule of thumb of these components in 2026 of how much leakage they have.
Yes.
Hey, so do you still have to do some more on this, or is
No, this one is done.
no problems?
No, of course no problem. Come on.
There
now,
are
cool
often
down.
problems, so it's just for the viewers to
Not
know.
on my pumps. That one's going to be a little more in-depth, a little more interesting. You might want to come out for that one.
Which one here?
The bigger of the two.
Okay.
This one's got a real unusual setup. It's got 2 different crossover relief and a POR.
I did film that whole inspection from beginning to end.
Yeah.
Great. Okay, this is going to be a good video then.
Yep.
Okay, stay tuned.
I hope you like that. You need to practice it. You need to look at the schematics, and you need to try to understand the sort of cause and effect of them. I think that this one was a tough one. We have a aerospace engineer, a student, who's going to be joining us. He's going to do simulations. So we have this hydraulic simulator. In a couple of weeks, hopefully we have some more helpful tips with simulations. We're working hard to get you your next content episode. Shoot us a comment or an email. Let us know what you want to see, and we'll see if we can make it happen.